So yesterday, as I was saying a minute ago here, we started our work with compound inequalities. The and statement, where we just had these two circles on the end. They came together in the middle. We talked a little bit about what our symbols look like and how we figure out what symbol happens at what time. Here's the good news. We're going to use all the same symbols, all the same hints on what way our arrows go today. The only difference is going to be one slight but important thing, and that's now we're going to see the word or in the middle, which is going to give me a hint on what my graph should look like. So here's how this goes. We're going to roll like we did yesterday. So if x is less than or equal to 1, I'm going to try and get this all back in at the same time. Oh, nice. We can do it on the first one. Okay. If the x is being pointed at, x, you are less than 1. Less than means we're going to be going left. And the or equal to under my arrow means we're going to have a closed circle at 1. And less than means we're going left. When I go to do my other one, my pen doesn't want to cooperate. Let's try again here. When I get here, I'm going to be at 4. Since there is no line underneath, we're going to have an open circle. And since the arrow is eating x, chomping it, getting greater or larger, my arrow is going to go. Arrow eating x, the arrow goes to the right. There's our difference from yesterday into today. Yesterday, the arrows came together when we had and, but now, when it's or, the arrows go out. So here's a way to maybe remember that. If you see or and out both start with O. And you can kind of think like and, in, or out. It's kind of like a really crazy dance move like maybe your parents would do because they're old like me. So, that's my graph. I'm done. All of your ors are going to look this way. If you ever do an or and they're coming together, something didn't quite go right. So just like we had yesterday, we will have some situations where we actually have to solve or reduce things. You will not have any three-parters with this, though. Any of those big, long ones like we did with this one. But again, or is going to give me a clue that my graph is going to go more like this. So if it's not already x equals, my first job is to get that x term by itself. So we're just going to do the opposite of plus 3 to both sides of the arrow. And once we have that x term by itself, we're going to do that one last step to get it below. The opposite of multiply by 2 is to divide by 2. Make sure that your x and your number stays on the same side of the arrow that it was. I can't randomly move those back and forth. And so I think again, and I go, okay, no line under my arrow. So it's going to be an open circle. The arrow is pointing at x. Remember what that means. X, you are less than I am. And less than goes left. Sometimes we can almost cheat and follow the arrow. When I get to my other one, same idea. I've got to get the -3 out of there. So I do the opposite. Get my x term by itself. And the opposite of multiply is to divide. And once again, just like the first one we did, there is no line under my arrow, no or equal to. So we stay open. The arrow is eating x. It is becoming greater, because again, as we eat, we grow. So it is becoming greater, and greater again is to the right. And what I'll do when we get done today with our notes is I'll bring that part back down with the open and closed circle and the greater and less than. So in case you missed it yesterday or just want an easy reference on the board, we can get that for you and work it that way. So keep these close. We're going to want to refer back to this as we get into today's a little bit. So in your bigger packet, in your practice packet, and I didn't date my notes. Why didn't I do that? I don't know. I'll do this though. So over with the OR inequalities, just like yesterday, those problems on the top that you're looking at are going to work exactly the same. And now I could label these with a date too. Exactly like your first one. They're already solved. All you have to do is make your graph on them. Okay? So the first 6 problems here are all like example number 1. So you can see how that works. Similar to yesterday, but we'll chat again about one of them. Write a compound inequality for each graph. You're like, again, that's not in the notes, but we got this. So what I'm going to do is I'm going to look at them one part at a time. So I'm going to kind of forget about this part for a minute. And I'm going to look and I'll be like, okay, the circle, open circle, is at -2. So I know it's just going to be an arrow. It's not going to be an arrow with a line. And to be honest, I look and it goes left. Left is less than. And less than means, again, the arrow is pointing at x. X, you are less than -2. So that's how I keep track of what direction my arrow is going to go. And so when I do it again on the other one, and I'm trying to see, does that look open? That looks closed to me. I'm going to make it a little more obvious if it wasn't, that that's closed. So over here, okay, my number's at 1. It's closed, so I know the arrow is going to have a line under it, but it's going to the right. Which is greater than. Greater than, the arrow eats the x. It becomes greater. But since the dot is closed, I'm going to put that underneath. Yes, sir?
I picked that number first, but I decided
As long as the question is, if we've got the numbers and things moved around, does it matter? As long as the arrow is pointing at X, you're fine still. Yep, absolutely. Nope. Nope. As long as, so to answer the question that's coming from the back here, let's say I put the -2 and the X in the opposite order. As long as the arrow is pointing at X, it is in both of these. These are the same thing. I could write it either way. Most of the time, do we have the X to the left? Yes. But not every time. So if those get switched around, we're still okay. So as I get to the rest of these, though, so let's say we're doing 12. This time, these down here are more like, and I don't know why it says number 3 when we only did 2 examples before, but I don't put the 3 because that's what we've got here. My first job, just like it was on those, is to get my variable alone. So how am I going to get this out of my way so I can get my t? What's my opposite going to be? Yeah, minus that 14 out of there. Both sides. That one, t's by itself, we're good. Over here, what's my opposite going to be? We're going to add our 9. If you're not sure on the signs, because we have a negative and a positive this time, again, there is no problem with going to the calculator and getting that in here. So once I've got them both solved, I have t by themselves. Here we go again. All right, we're going to 1. Line underneath. Closed in circle. And when the arrow is going to the right, when it's eating the t, it's eating the t and getting greater than. That arrow just goes to the right. Or t, okay, we're at -1 now. No line underneath the arrow. We've got that. And the arrow is pointing at t, which means less than. T, you are less than. And again, less goes left. Greater goes right. Do you have to write that on everyone? No. But if that's one of the struggle points, you're like, I don't know what way the arrow's supposed to go when he does this. That's the easiest way to roll with it. Is to kind of start getting used to less is left, greater is right. As we see how these work. And again, they're going to kind of keep coming back in some different forms even when we get done with this part of the lesson. So nothing too bad. So, okay. Now we get into some kind of funky business here. So, first things first. So I get here to the back, and I start to look, and I'm like, okay, some of this is kind of funky. So I actually want to roll through these with you because something weird is going to be going on, and I want to make sure that we don't have ourselves into a problem here. So what would the graph look like for the compound inequality? You're like, well, if it's like the ones we were doing yesterday, I'd look and I'd make my graph and I'll put my points down. Every time when we were doing them yesterday, it was just, oh, it's those two end dots and I'm coloring in the middle. What's the big deal? Here's the thing. Occasionally something weird is going to happen. So if I just look at this piece, the arrow is pointing at x. X, you are less than 3. So you'd be like, okay, less than is left, all right. No big deal so far, Hardy. What's the problem? Oh, just wait. Wait a minute, the arrow's pointing at x again. Pointing at x there and pointing at x. Wait, x is less than 5? But wait, why? They're going the same way. Like, did I do something wrong? No. Okay, this is a special case. I'll admit the person doing the problem probably made a boo-boo somewhere. But this is just to let you see again that occasionally you may get a weird one. It's not going to happen often, but it can. So you're like, okay, so does that mean they're all going to start looking like that now? Well, let's see. Let's try this again like we did 13. Let's do it in pieces. This time, is the arrow pointing at x or eating it? It's eating it. So if it's eating x, it's becoming greater. X is greater than -2. So if it's greater, which way does the arrow go? Greater the arrow, oh my gosh, I can't even get that up there. Greater the arrow is going to go right. And I look, and I do the other one. Arrow's pointing at x. X is less than -4. Less than goes left. You're like, well, wait a minute, though. That looks like the OR ones that we just did today, but that's a compound. It's possible to have that. Did I just do something funky? I did not. Okay. So again, it's more to show you that sometimes things will not always be what they seem. Not to say that we're not doing it right. So last one. Last one, and I will give a couple of hints on the review and you'll be good to go, I'm hoping. X is greater than 2. We're eating the x. Or x pointing at x is less than 4. Now here's the weirdest one of the group. Normally I would look at 15, you're like, okay, the arrows are going to crash into each other. It looks like the ands from yesterday. But wait a minute. It says or, it doesn't say and. Here's what the difference is now. It's going to go straight through that other piece. You're like, now wait a minute. Why does this get to go straight through? And when it was and, it had to stop. Here's the reason. Okay. And stops. It's sort of like this. Now again, I make weird comparisons at times, I admit it, but most of the time it sticks. I like to compare and or to like when you have friends, okay? You have some friends that are like, okay, that person, I'm not too sure, and they have a very small group. That's your and group. They're picky. I only want this little group right in here between these two spots that do these things. If you see or in the middle of something, oh my gosh, everything's a party, everybody's your friend. So or says, you know what, I'm not going to be restricted just between these two dots. I'm going to keep right on going forever. And that's how I want to kind of have you look at these. The ors have arrows, they go forever. Ands, they want to be in their own little place, and that's okay. But they're a little more restrictive, okay? And stops. Okay, it's restrictive. Or just keeps on going and going. Okay. Okay. Last hints for the day. I appreciate your patience today. I'll give a hint on that. I'll give a hint. I want to do one thing on 17, though, first as a hint. This 1/3, you're like, Hardy, do we want to just multiply to get rid of the fraction? That's going to be more work this time than we want. Here, if you multiply by 1/3, that is exactly the same as dividing by 3. So let's do this first step, then I'll leave you on your own for that. What's 6 divided by 3? 2. And 9 divided by 3? 3. That's a whole lot easier looking than the rest of this is. And then I just work on getting my x's together and solving. Reminder from yesterday, if you have fractions, you're going to multiply the numbers that are different together. Notice I didn't do the 6 because I already had one here. If you multiply those together, 6 times 3 is 18. And we're going to multiply, we're going to distribute that 18 all the way through with one reminder. When you get to the fractions, make sure the fractions go in parentheses, or you'll get a few things that you're not really hoping for. If it's just a plain old number, then just multiply it. You're fine. Because 5/6 of 18 is 15. 18 times 5 is 90, divided by 6 is 15. Okay. That's why we have the calculator as our backup option. So we can always make sure that we can do that if we need to. Okay. And then I'll leave the rest to you because I want you to get practice with putting those fractions in and seeing that they come out as whole numbers. Last clue. HJ is the angle bisector of GHL. It cuts it into 2 equal pieces. Equal pieces. There's your equation for you to be able to solve. So again, use the time now to practice. Make some mistakes. That's okay. Struggle with some stuff. But where you've got some support with me, the key is online. The key is up front. If you need to be able to check on something. And then again, enjoy your weekend, but if you've got some stuff to get finished up, make sure you're on top of that, because next week we're looking at our next quiz on these things.